How's it going, everyone? Euler Gonzalez here again, but in today's we're going to talk now about is the managing state as a way to move on directly to the learn sections of the React docs to understand how these things work and do that in the most succinct and possible way to describe how do we get here. So, as a way to describe this, because this is part of the React performance series, by first understand generally how the React rendering works behind the scenes, okay, which is a course taught by Steve Keeney, head of front-end engineering at Temporal, these durable execution platforms. So you can think of this like some sort of orchestration system like Kubernetes, which is an open source, but for the specific use cases. For example, Temporal here is being used by Next. So Temporal here, they don't have any good Temporal.io. They don't have any good that, but is this, right? Which is actually used by other components as it is. For example, Coinbase, ClickHouse, Nightfall AI, and that kind of thing. So co-business logic, not plumbing. What if you could avoid the complexity of failure and focus on only what matters? This is a promise that everyone actually is giving to you. And this is an open source component, Temporal Services. And it is written in Go. That's quite interesting. Try the Temporal UI, the web UI. Number of hours too is a way of how you can interact with that. You have experience with backend applications that rely on external API. Ask AI. Powered by Kappa.ai. Instant AI answer to technical questions. Trusted by 50 leader community. How Kappa AI works. Apply AI at OpenAI. Yeah, because it's a knowledge. Deploy Kappa AI where your users have questions. Discourse, Sense Desk. SOC2 type to certificate, P data anonymous. Backed by G Combinator. Why am I not surprised, man? Why am I not surprised? Exactly, because we are now dealing with the scalability issues, bro. We are now dealing with scalability issues. Mm-hmm.
Hi, everyone, and welcome to the Kappa podcast. Super excited to have Jerry Liu on today. 1,000 stars, and now that's almost at 8,000, right? So, building.
Yeah, so I think it was actually probably a combination of like a few different factors. One is, I've always been interested in generative models. I think the first AI model I've ever played around with was a generative adversarial network. And so this is back in college, back when I think GANs were one of those things that, they generated some pretty pictures. And that was the moment where I thought, hey, this is actually really cool. These images actually look somewhat realistic. I want to play around with them a little bit more. So I've kept tabs on,
Hi, everyone, and
generative
welcome
models.
to another episode of the Kappa podcast. I'm super excited today to have Joyce Lin, Head of Developer Relations at Postman on. Joyce, why don't you go ahead and say hi and start the interview off by introducing yourself and what you do at Postman?
Yeah, thanks for inviting me. I'm the head of developer relations at Postman, and I'm guessing most of your people, most of your audience is probably pretty dev-centric, so maybe they know Postman already. Okay, so Postman is, right now we're like 25 head of developer relations at Postman, and I'm guessing most of your people, most of your audience is probably pretty dev-centric, so maybe they know Postman already. Okay. So Postman is, right now we're like 25 million developers and testers and DevOps.
Big pillars, the big initiatives you guys look towards.
And right now, developer relations is advocacy, community, and then education. And so, again, that's changed over the years, and every year we have a different sole focus, but that's our focus right now.
A little bit hard to define at times.
Yeah, and I started as a developer advocate at Postman, and I've been with the company almost 7 years now. So advocacy has changed a little bit at Postman, and this is another question. I love seeing like what do advocates do at other companies, and at Postman, it's you can think of it more as an advocate for the community. So yes, we are in charge of like communicating new releases and educating people on like proper workflows, but it's really understanding the day in the life of the community so that you have the empathy for when a new feature comes out and it meets certain needs, then you know who to talk to, and when it doesn't meet certain needs, then you're talking with the product team.
Gotcha. And when you talk about sort of the Postman community as a whole, is there like a central meeting place? You'd say like all the community always gets together here to have conversations, or is that more of almost like a concept that puts the forums, the videos, the live streams, everything together, in-person events, meetups?
No. That no central meeting source exists for any community, I would bet. Yeah.
No.
So it's everywhere developers exist, right? Everywhere testers exist, and some people are, strictly online. Other people like meetups, in-person meetups. Other people are in the forums. Other people are on social media. Yeah. And there is some overlap, but it's so disparate that you almost have to be everywhere to meet your developers where they're at.
Yeah, I think that's probably the unfortunate but kind of true answer given just the complexity here.
Yeah.
I'm curious now, having thinking about sort of DevRel Postman for the better part of 7 years, you said. How's that changed since you started out to today? What has the overall sort of shift in how you view developer relations changed?
Yeah, I mean, there's a couple insights that I've gained over time, but it's really about the stage. I keep saying stage, but you know what I mean? You're still finding product market fit, then you're going to be focused on awareness, or you're trying to break into adjacent segments, and then you're just kind of thinking about terminology and just understanding the space a little bit deeper. A couple insights that I've learned over the years, though, are one is when I first started at Postman way back when I was knee high to a grasshopper, we were already 3 million, like a community of 3 million developers, right? So I was really trying to create content like I was one of the first in developer relations, and so I was just trying to plug all these holes because we had nothing about APIs or like just basic content, documentation, all of that super basic. So I was trying to plug the holes, and at that time, it's trying to talk to the broadest segment possible. So even if you'll look back at some of the early content, it's super broad, super general. But then after a time, you can't be so broad and so general. And in fact, some audience will rebel against that, where it's just like, developers are not all the same. How come you don't talk to me? I'm a test engineer, or like me, I'm a DevOps engineer. I don't identify as a data engineer, and so everyone has their own identity. And so the more specific and targeted you can be with your content, it ends up being better. But in the beginning, you can't do that.
No. There's just limitations on it. Maybe one to these kind of...
And if you can be so lucky, you start to have self-organizing community, right? Outside of people who get paid to organize.
Anyway, this is CAPA as a way to have a one place. As a way to have one place where people can now. Interesting. Anyway, to me it's quite interesting that. So we're going to describe this quickly about now what React actually does, and as a way to now finally getting here, which is a sharing state between components, and then preserving resetting state and extracting state logic into reducing. So how do we get here? React, after all, allows us to describe UI. All right. So first we look at how can we create our components. How now can we import or export our components? How can we now bind is the JavaScript to our HTML using the JSX? Also rendering is conditional components. How that is something that at the end of the day, this rendering or this component that you are returning from JSX, from React components, which is a JSX, they are not new instances. They're not instances. In fact, they're just blueprints. And understand this difference is something that we're gonna see in the next topic, which is preserving and resetting states. Okay? So then we also look at how can we render list of elements, how important is to set is the key as a way to notify is the React, hey, this is the order, right? I want you to now be able to identify this, so when you change each one of those elements on the list, you can render that properly, right? So pretty much like when you go to your kitchen and you have all of your silverware organized, right? So forks, spoons, little spoons, knife, that kind of thing. So if you don't have at least an index, so let's say you grab all of that and you put it into one bucket. So it'll make a mess to actually figuring out what is a spoon or a knife. Another example is that if you have a folder with a lot of these files, so what ends up happening is that if you don't have a way to keep track then, so if you remove a file, which file was that, you know? That's one of the reasons why we use key here. And also the importance of why we need to create our components in the pure way. In a pure way is that doesn't affect is things that are outside of that scope, of the function scope. Why is that? Why do we care about this? Well, because now these components can run in any environment as long as it is run JavaScript, whether it's on the client, on the server, or on the workers. And also, you can now prevent these components to re-rendering, okay, by memoizing, which now it'll make your components easy to catch. Okay, so if this component actually doesn't change, this is what you're gonna send to the client. And also, when you're going to pass down data, you can stop that execution in a safely way. And this passing down data is the way how now this React see these components. So we got now is the React render tree, which is the way how now you can, so React represent is this UI elements here in a tree data structure. Tree data structure is just a computer data structure. It's just a way of how you can now organize your data, pretty much like if you have a fridge, and your fridge you put only fish there, right? For example, if you wanna put there is frozenable items, food, meat, or perhaps some other things, like let's say you want to you want to put ice cream, okay? You have your backpack, okay? When you put all of your, for example, your laptop, pencils, notebooks, but you don't put your notebook on the fridge, right? Or you put is your ice cream on the backpack. There are not, I mean you can, but there are not good places to where you can put it, okay? So that's what this data structure allows for us. They give us is now the ability to organize the data in a way that see fit to help us with these particular problems, okay? So in the case of data structures like tree, it allows us to not only to access elements, traverse elements, and remove elements, edit elements in less than linear time, in a log n time, which means that no matter how big this data structure grows, you will now get your data fast. You're gonna add or remove elements faster, and you want to be able to find elements there quickly. So this is one of the idea here. You can think of this as that as your fridge grows, okay, you now have a way of when you're adding fish, ice creams, or any other items, anytime you want to find them, you can retrieve them quickly, you know, or you can modify the order quickly, right? So we are talking about now scalability problems. Scalability. So in the case of the React, we use now is this render tree, all right? Where now, once you understand that, you can see how the data flow go through, as well as how all of these components are rendering. AKA, you can now check out for performance issue. And when we also look at the tree dependency, which is what is the logic that you have to apply, or the necessary logic that you apply to each one of those components, UI elements, React components as a way to say, hey, we would like to now only use the bare minimum code anytime we send that to the client, from the server to the client. So you can now actually fine tuning about what are the data that you want to send, especially what are the utility functions that you want to send, and be much more efficient and effective with your components. So with that, now that we understand how can we describe the UI and how the data flows, as well as how React see these UIs as a render tree and the tree of dependency, then when we want to add interactivity to this, so for example, like now how we can connect our components to the template when you listen to a particular event, okay? Binding is the handlers to a event. And also, not only that, but what happens when you want to show data in a persistent way, or when we want to update data in these UI elements. So for example, when you want now is to show is the balance or the transaction history, okay, your bank account, all right? So states is this components memory, where it allows us is to now, by defining its a state that is using its closure, which is one of the nice bonus features of JavaScript, that when you return a function from another function, it gives you now the ability to persist is the state of that outer lexical scope. That might go beyond the scope of this, all right? But it's important to understand that one of the patterns or one of the use case of closure is, in this case, using as a state. So that's going to store this state, this data, in memory. And once we do that, we're now going to notify, so once we define the state, and when we want to update the state, we notify React to do something. And that is the rendering commit phase, which is the mechanism of when you change this state in your components. So React pass through this series of steps, this mechanism, which is trigger. And this can be caused by the initial render, okay, or it can be caused by a component state updates or any of its ancestor. So once React detect that, it say, all right, now let me render. And here what it means is that let me now call is that component. So it's going to render is whether it's on the initial rendering or when that component cause that state updates that trigger that rendering, okay? It will call that React component, it get a GSX element. This is going to evaluate if this GSX element now contains more component, and if it is, it's going to look at the props, and if those props change, it's going to store that information for a moment, because it will going to use that data on the next phase. So if when calling these React components, the GSX contains more React components, it will continue to call them. That's one of the reasons here it is important to understand this, because this can lead you to performance issues, especially when you're calling or when you're setting the state higher in the render tree. So it will cause now to call all of these components. And once that phase is over, now it is time to commit those changes to the DOM. So if that happened on the initial render or on the entry level, Well, it's going to use the append DOM API as a way to put all of these DOM elements to render the page. But if that was caused by a re-render, and the commit phase is say, all right, now let me see if those component states are if they are different between renderings, meaning if they are different between this React components, this GSX, and if it is, let me now apply the necessary change to that. So why this is important to understand and to describe? Because at the end of the day, this is something that you're going to do, and React is doing that for you a lot of the time. Fast. And lastly, once the React apply those DOM updates, the browser detect that and say, oh, some DOM element changed, let me paint this. So once we're able to understand that, and this is the rendering process of React, and when you want to now know how to work with your data, it's important to get to understand that or to look then as a snapshot of data, snapshots, where these snapshots, aka the state's value, will change in the next render, and during the event handler, the React fix the state value until the next render. And if you want, for example, now to queue a series of states updates, you can do that. And this is this is actually not that common, but it's important to understand that, hey, you can do that. You can actually batch a series of state updates. Okay? When we can use this? What is the utility for that? For example, when you want to trigger several updates before a render, let's say doing an async operation. Okay? When you're handling in your event handler, when in your event handler, you are now is when in your event handler, okay, yeah. When in your event handler, yep. So when in your event handler, you can now, that makes a lot of sense. Completely. Exactly. So when your event handler, okay. So when in your event handler, you are dealing is with async operations. That's when you perhaps want to use this in queuing, or to a queue as a series of state updates. We also look at how can we now update object in the state and arrays, and at the end of the day, it is important to you to always return a new state of that. Why this is important? Because now this is something called, this is when you mutate the state, okay, especially in an object. This is now for the JavaScript language itself, and also for Java. When you those people that come from object-oriented programming language, okay, they know that when they modify a state, it can cause ripple effect through the entire application. So how can we mitigate that? There is some sort of patterns like solid, okay? So single responsibility. Hey, this object must have one single responsibility, close to modifications, open to extension. The list of substitution, is this subclass based, or is this subclass object must replace is the base class. The other is the interface segregation, which is, hey, instead of having one big giant object to operate that, it is much more better to have several interfaces that we can consume that. For example, you can think of this like a Swift knife, all right? When they have all of these different interfaces and all of these different things where we can now use them, right? Instead of having all of them at once. So if you have all of them open, of course, it is hard to work with them. So if you only have one at a time, okay, when you have now this segregation of all of these different things that you can do at a time, when the consumer, when the user, you can actually apply, that'll be better for you. So, and lastly is the dependency inversion. Is like, hey, high-level objects or high-level models should not should not import low-level model here. They must rely on some sort of abstraction here. This is something that is go beyond perhaps the scope of this. I mentioned that as a way to flex and also to describe the reason why we don't mutate objects, okay? Because it's quite hard to actually keep track of all of this. Not to mention is to keep in sync all of that. So it is better to return is a new state out of this, which comes from the functional programming. Better always return a new state and tell them this is the new state to react to the state. When you're going to update that, this is the new state of that. So this is something interesting, powerful, as a way to understand now how can we describe your UI, how can we add interactivity. But when it comes to actually the grown-up problems, okay, the problems of big boys and girls, okay, the problems of big people, right? Now it is important to look at how can we manage our state as a way to first understand that how can we now what is the approach that React allows us, what is the approach that React what is the proposal of React when writing these UI elements, okay, in a declarative way, and why not an imperative, and what is the trade-off between imperative and the declarative, which imperative is pretty much like you're telling the taxi driver where he need to run, where he need to turn around. Hey, do this. No, let's do this. And on the next two streets, let's go to the right, and then on the left, and that kind of thing. You know, so it actually is very, very this precise. You're telling how to do things. We're now in the declarative mode. In imperative, you have much more fine control, which is something that you might want. And when it comes to build things that are more scalable, okay, the declarative way, it seems to be much more maintainable. So instead of telling to the taxi driver where to turn around, where to turn, now you tell them, hey, you mentioned, hey, this is the hey, this is the place I want to go, right? This is the destination. So in the case of React, how you do that? Well, by following this particular way of describing the UI components, which is visualize all the different states here, okay? So visualize all different states. So identify all the different visual states, then determine what trigger those states change, and then represent those states in memory using a user state. So now you can remove any non-essential, okay, non-essential states, and then connect those states, and then connect the event handlers to set this state. And that's something quite interesting, because when we look now at the state structure, okay, that we need to follow, which is something that comes from the database engineers, this normalization is like eliminate redundancy, and the eliminate redundancy, eliminate redundancy, and avoid duplications of data here, is to now look at how, and I want to make a quick pause here, because now when we look at how can we describe our UI, pretty much like the UI designers, and when it comes to maintain the state with the data, is now doing that the way how the database people, database engineers does, okay? It is interesting how now these two fields are combined as a way to provide now this user interface, this rich user interface, which are faster. So when we look at the state management as a way to say, all right, now React provide these principles that you should follow as a way to say anytime you want to organize your state, okay, especially if you want to manage in your state, if you want to now wait for how you can now create these components, or scalable React applications that allow you to know how to structure your state and how to state updates logic maintainable, and how you can then pass down data to your to distant components. By looking this, all right, first we look at how can we structure states. It's like group state related, group related state, okay, so group related states, then group related state, okay, like so. Yeah, group related state as one. Group related states that's one of the principles. Avoid a contradiction, having the states that contradict or that go against them is like avoidant. Avoid redundant states, which is, hey, can we use the data that comes from the props or that comes from the state instead of actually creating a new state from that? Can we reuse that data? If it is, go ahead. Avoid redundant states. The other is avoid duplicating a state, which is, hey, we're going to create this new state that is just an instance of this another state, all right, which is a fairly common use case, I might say, as a way to now keep track all of these different states. So if you have duplicated state, it becomes harder to maintain. I'm figuring out this when I define this state here. It's like, if you define another state here, it becomes quite harder to actually to keep in sync, you know? It becomes quite harder to keep in sync with that. So you are now looking at the real time is that, which is this, okay? Which is this, which is GSX. It's like avoid. This is not a state structure. State structure. What the fuck? State structure. uh, so group related state. Okay, group related state. Avoid redundant or avoid contradiction state. Avoid avoid redundant state. Avoid redundant state. Okay, hey, can I avoid redundant state? Okay, hey, avoid redundant state. Hey, oh my god, avoid redundant states. Hey, can I use information? Can I use information from its props? Exactly. Can I use information from its props or state? Okay. The other is avoid redundant, avoid duplicate states. Avoid, what the hell? Anyway, avoid duplicate state because it becomes harder. Because avoid duplicate state because it becomes harder to avoid duplicate state because it becomes harder to keep them in sync. Yep. And the other is avoid deeply nested object states. It's like quite frankly, it's like no, don't do that. So once I looked at, and when it comes to dealing with UI patterns like selections, use ID instead of the object itself. And also how you can now, all right, use an ID and a map for multiple selecting, which to me was like, what the F is this? For multiple selecting, men. This to me was quite interesting, because this is the way of how you say, okay, let me actually select the IDs and selected IDs, where here I'm going to create is a new JavaScript building object called set that only store is unique values, all right? And to cover is this particular use case, now instead of selecting the count here, okay, we're going to see is this. I want you to represent all of this selected here, okay? And if that ID match with the current element ID, then I want you to now show this as selected. That to me was quite interesting. You have now this map here, or this set of unique value. You can pretty much think like a table, okay, like a table, where now you only have these unique values, all right, pretty much like a spreadsheet, okay. This is a spreadsheet where you have only unique values, period, all right. So each column you store is a value here, a unique value, and then with that, then you can compare that to your UI elements here, to your index in that. And it is interesting because now when we are rendering list elements, all of data must come, all of those index must come from the database, okay? Otherwise, you can use the UUID as a way to generally, in a cryptographic unique way, is all of this index. Holy moly. Yeah, got it. Oh my god. Exactly. So once you define this as a new set, right? When you define this as a new set, you say, hey, when you are handling is this, when I listen to this from this base component, this will trigger now the change here, the on change, which is on the letter here. This must trigger is that come from the input checkbox, okay? And it's in there what we have now. Here we can, what we can trigger here. You can trigger is the letter ID. Exactly. Hey, passes only the ID, so you can now have, when you have these UI pattern selections, you're gonna hold is this UI elements here, okay, as a set, and then you're going to compare that. All right. Why this is important? Because with sets, we can pretty much think like a hash table, where now it's much more performant, because now the access times is, you can think of this usually linear time. So you're gonna get those updates pretty fast. Unlike if you use an array, but it will take quite time to do that. So you take linear time to actually go through that element and say, okay, yeah, exactly, I did this. Perhaps for small items or for 10 or 100 items, it's not a big deal. But when you started to show them is 500 elements, but with other React components and all of these components is rendering, and you have all of this small bottlenecks, little tiny bottlenecks. So now as your application grows, you're going to see that. So in any case, I think this is quite interesting. Very, very interesting. Totally. So here we're sending is the ID when that change, okay, to notify here, hey, what you gonna do with this ID? Because now I get this ID, and as a way to update is the state in this component. So we need to generate is a new object here by saying next IDs. That'll be a reference, new set. That'll be a reference to the selected IDs, okay? Where now we're gonna check if, hey, if this next ID, which is this set, okay, this hash table, if this selected ID, which is this next ID, has is the toggle ID, if it is, then I want you to now is on the next IDs, okay, delete that, toggle it ID. So I want you to delete that as it is. Yes, I want you to delete that. Otherwise, if that exists, okay, all right. If that doesn't exist, I want you to now append it, which is next IDs dot add the toggle ID. And then is when you're now going to actually is update the state. Next ID is this. So here what you're gonna do here is that hey, this props that you are receiving is selected. We're now going to check is that when you are rendering is that element, okay, when you're rendering is that element, I want you to now check my current state selected ID to see if that actually, to see if you have that. If it is, please return is a boolean here. Hey, I already got this. Selected ID has letter ID. All right. selected like this. Exactly. Selected like this. And anytime you rerun this, you can use the selected count. Okay. You can use this selected count to say, hey, this is the selected count, which will be is the selected id.len. So anytime this size, this is a map. And now this worked as expected. Holy moly, bro. This is one of the beautiful things of using is this data structure combined with this. So on the sharing state between components is to think about is that you must have a single source of truth. And this is when you want to share, when you want to share components, or when you want to different components share in a state. This is known as lifting states. Okay, and here is a particular way of doing that. It's like, well, eliminate those states there, down there, put them as props, mock them with some hard-coded data, so way to, hey, this actually is working as expected, and then you add the common state to the common pattern. This is just as a way to have this now single source of truth. Okay, and they call this as controlled or uncontrolled form, because now they say that this is controlled or uncontrolled when you have now local states in there. So these components are not flexible. So when you have a component that has its own state, they call this as control component. Whereas when you have a component whose states, whose behavior depend on its props or other components, now this is known as uncontrolled component. I mean, this is now is known as control component. They call this as a way to talk about how components are designed, design components, and what capability they offer. What are the behavior that they offer? How components are designed, and what capability they offer. That's one of the reasons why when you talk about components, they call this, and as a single source of truth. So now here we also use that. And here we are now looking at the preserving and resetting states. Okay, so preserving and resetting state. Here we are. State is isolated between components. Exactly. React keep track of which state belongs to which components based on their place in the UI. Completely. React keep tracks of which state belongs to which components on their place in the UI tree. It's like, hey, I'm keep tracking of which state belongs to which components on their place in the UI. Keyword here, keep track. You can control when to preserve state and when to reset it between re-rendering. Hey, I want to preserve this state. Hey, I want you to reset this state. When React choose to preserve or reset the state. Interesting. How to force React to reset component state. How to reset component state. How keys and types affect whether the state is preserved. Okay. State is tied to a position in the render tree. Okay, state is tied to a position in the render tree. React build render trees. Something that we already mentioned, right? So there is no need to actually look at this. So React build render tree from the component structure in your UI as a way to keep track. When you give a component state, you might think the state live inside of the component. As a way to think of it, okay? You might think that the state lives inside of the component, but the state is actually held in React. Okay, it's React that keep track of the state. So React is what, a closure? Is React a closure? React associate each piece of state. Okay, React associate each piece of states it is holding with the correct component by where that component sits in the render tree. In other words, React associate each piece of a state it is holding with the correct component by where the component sits in the render tree. So you can think of React like having some sort of hash to where it say, hey, this is the state that this component has, and this is the state which is a closure. Holy shit, a closure that this component's reference has, that this variable here. Here there is only one counter. Exactly, here there is only one counter, GSX stack, but it is rendered on two different positions. So you got the counter here, but they are rendering in two different positions. So states is tied to the position in the render tree. Okay. So here is the only, here there is only one counter. We create that in the app tab, okay? GSX stack, but it's rendered on two different positions. So we have one component here, instance, that is rendered in two different places. Okay, so state is tied to the position in the render tree. Holy moly, bro. So it's pretty much like you're creating this new instance here, right? God damn it. Holy mo. So states is tied to a position in the render tree. Gee, states. Okay. Here's how this look like a tree, because you have now is the entry point, which is a div, but you have now a counter and a counterers, two counter components as sibling. Exactly. So states is tied to a position in the render tree. Makes sense. It's actually following is the it's following is this tree. It's following is the tree structure here. Okay, a state is tied to a position in the render tree. So for example, if you put this now a div here, like so, right? So this state is tied to the position in the render tree. So hey, this is tied to the position in the render tree, this is tied to the position in the render tree. But states are tied, or this memory are tied to the this, when say state in React, is memory. So this memory, so the memory is tied to the position in the render tree. So this memory is tied to the position in the render tree, or the state is tied to the position in the render tree. These are two separate counters because each is rendered on its own position in the tree. Exactly. These are two separate counters because each is rendered in its own position in the tree. You don't usually have to think about this position to use React, but it can be useful to understand how that works. So states are tied to a different position. So states are tied to the position in the render tree, or this memory here. Okay. So, so in React, each component on the screen has fully isolated state. For example, if you render two counter components side by side, each one of them will get its own independent score and hover state, like so. Exactly. Which means that when you see things like this, if they contain states, they are tied to the location. So this memory is tied to the position in the render tree. Okay. So as you can see, when one counter is updated, only the state that component, only the state for that component is updated. This is now to talk about is uncontrolled components. Uncontrolled components. How do we design components and what capability they offer that? React will keep the state around for as long as you render the same component at the same position in the tree. Exactly. To see this, increment both counter, then remove the second component by unchecking. Render the second counter, checkbox, and then it back and ticking again. But React will keep the states around for as long as you render the same components at the same position in the tree. As long as you say, to see this, increment both counter, then remove the counter component by unchecking, render the second counter, checkbox, and then add it back by ticking again. So increment both counters, okay, then remove the second component by unchecking render, then unchecking here, which is you're gonna remove is the second one, exactly, given this logic, okay. And then add it back by ticking it again. Oh. Okay, now you are resetting is the state here. By doing this, you are now giving is like an instance by default. So you remove the memory. Okay, it's like you are freeing the memory here. Good. You free the memory, and now you have this new one. Okay. Holy moly. Exactly. Deleting a component, notice how the moment you stop rendering the second counter, its state disappear completely. That's because when React remove a component, it destroyed its state. It releases the memory for that. Okay. So once you remove an element, once you remove a component, it is destroyed its state. It is release that memory for them. And when you tick render on the second time, its state are initialized from scratch and added to the done. React preserves a component state for as long as it is being rendered at its position in the UI3. Jesus. If it gets removed or any, exactly. So React preserves component states for as long as it is being rendered in its position in the UI3. So it's gonna React preserve the component states or the memory for as long as it is being rendered at its position in the UI3. If it gets removed or a different component gets rendered, or a different component gets rendered at the same position, React discard its state. Same component and the same position preserve this state. Same component at the same position preserve this state. So by adding one here, and then use fancy styling. So in this example, there are two different counters. There are the fancy or not. When you tick on the clear checkbox, the counter state does not get reset. But this is same components at the same position preserve state. State is tied to a position in the render tree. Same component at the same position preserve states. But two separate counters okay, you're creating a new state from this when they are next to each other. These two components, because each is rendering in its own position in the tree. Because each one of them are rendering in the same position in the tree. Same component at the same position preserve state. Same component at the same position preserve state. Same component at the same position preserve state. So for example, if you do something like this, same component at the same position preserve state. Same component at the same position preserve state. Same component at the same position preserve state. Okay. It is the same component at the same position, so from React perspective, it is the same counter. Remember that this is the position in the UI3, not in the GSS. Okay, not in the GSS markup. That matters to React. This component has two returns clause with different counter GSX. But in the GSX here, you actually not. Because I'm generating a new state from this. Remember that is a position in the UI3, not in the GSX markup. use fancy style, use fancy style. Exactly, it's preserving in that. But if you, for example, remove his, no, it's gonna complain, it's gonna cry about this. But you, for example, say something like this, you are generating a new state, my friend. Not in the GSX markup. This component has two return clauses with different counter. GSX tags inside and outside of the if. But if they are on the same position, it preserves the state. If they are in the same position, it preserves state. But because they are not in the same position, in the DOM, in the UI tree, not in the GSX markup, that's what happened. You may expect the set to reset when you tick checkbox, but it doesn't. This is because both of these counter tags are rendering at the same position. React doesn't know where you place the condition in your functions, and it all sees is the tree you return. And it all sees all the tree that you return. And it all sees the tree that you return, which is a GSX. In both cases, the app returns a div with a counter as a first child. To React, these two counter exactly. In both cases, the app component returns a div with a counter as a first child. So to React, these two counters have the same address. The first child of the root. This is how React matches them up between the previous and next renders, regardless of how you structure your logic. It will use this. Different component at the same position. Different components at the same position reset state. Holy shit! Exactly. Different components at the same position reset state. Here you switch between different components that at the same position. Initially, the first child of the div container contain a counter, but when you swap in P, React removes the counter from the UI tree and destroys its state. Div, exactly, and destroy its state because you remove that element there, and from that, when content changes to P, the counter is deleted and P is added. Also, when you render a different component in the same position, it resets the state. It resets the state of its entire subtree. Okay, it resets the state of its entire subtree. Exactly, with at different positions, it resets the state of its entire subtree. God damn it, bro. It reset the state of its it reset this. So if you have different components, so when you render a different component, React components, so when you're rendering a different component in the same position, React reset state of its entire subtree. It reset its state of the entire subtree. God damn it! So when you render different components in the same position, That's okay. That makes a lot of sense when you change props and that kind of thing. If you s- if React, so if you render different components at the same position, React will mhm, React will reset the state of its entire subtree. As a rule of thumb, if you want to preserve the state between render, the structure of your tree needs to match up from one render to another. If the structure is different, the state gets destroyed because React destroys state when it removes a component from the tree. Because by removing a component from the tree and if not and they don't have the same structure, then React say, hey, this is a new instance. I'm going to this is a new state instance. So I'm going to reset all of those. But you're going to reset is the state. Is interesting. It reset the state of its entire subtree. God damn it. Pitfall. This is why you should not nested components functions definition. Here the my text field component function is defined inside of my component. This is why you should not nest component function definition. Resetting state at the same position. They might appear in the same place in the UI, but is a counter for Taylor and another is for Sarah. There are two ways to reset the state. Okay, render component in different position or give each component an explicit identity with key. Mm-hmm. In different position. Okay, in different positions. Okay. And resetting state with key. You might have seen keys when rendering lists. Keys aren't just for a list. You can use keys to make React distinguish between any component. By default, React use order within the pattern first counter, second counter to discern about this. Mm-hmm. And this is how you say, hey, preserve the state, or resetting state with no resetting, exactly resetting state with a key. Mm-hmm. Resetting state. The keys are not globally unique. They only specify their position within the pattern. Resetting a form with a key. Oh, okay, resetting a form with a key. Mm-hmm. Mm-hmm. Or by rendering them. By saying something like key to. And when you select this, so I know how to reset the state, and it's by calling is that here. Oh, because this, okay. Oh, an ID. And this is now how you reset is the state here. That's quite interesting. Preserving state for remove components. Okay, so things starting to get more and more deeper. Okay, okay, good. Jesus. Well, Jesus. That'll be all for this video. Yeah, take care. Bye bye.